Alright, so in this video we're going to solve an absolute value inequality. So basically this plays out in a very similar way to solving an absolute value equation. The steps are still going to be similar. We're going to isolate or get by itself the absolute value. So isolate the absolute value. So in this case, this guy right here, I got 4x minus 8, the absolute value of 4x minus 8, and I'm just going to get that by itself. So pretty simple in this case. I'm just going to add 5. So I'm going to have the absolute value of 4x minus 8 is less than 16. And so we're already done. Now, just like the absolute value equation, with an absolute value inequality, we're going to, again, create two different inequalities. So we're going to create two inequalities, which is going to create two parts to our overall solution. So if you remember from the equations video, the first inequality, we're going to branch off and just write a simple inequality as we see it. 4x minus 8 less than 16. It's pretty much the exact same thing we wrote down above, except we got rid of the absolute value. Second one is going to be, and we wrote this down before, but the thing that we're going to do is we're going to reverse the symbol and take the opposite, and take the opposite. We wrote this down. So basically this is going to be the same rule for inequalities. So I have 4x minus 8 is less than 16, and I'm going to have 4x minus 8. I'm going to reverse the symbol, so less than is going to become greater than, and I'm going to take the opposite of 16. So I'm going to take a negative, and it was 16, so negative 16. So now I have two different statements here, right? I got two simple inequalities, and I'm going to go ahead and solve them. So 3 is going to be to solve. So we're going to go ahead and say 4x minus 8 less than 16. All right, so we're going to solve this. Add 8, right? We get 4x is less than 24, and divide by 4 to get x is less than 6. And then if we solve the one on the right, we're going to add 8. So we'll get 4x is greater than negative 8. Divide by 4. Now remember, if we divided by a negative or multiply by a negative, we would reverse that symbol again. Here we don't have to. So we have x is greater than negative 2. So now we have two statements, and these are just showing us the solution set of our overall system here. So if you look at these two statements and we were to, let's just kind of graph this out, right? We have our first statement, which says x is less than 6. So let's say we got maybe 0 in the middle, and then we go 1, 2, 3, 4, 5, 6. Let's say 6 is over here. We're saying x is less than 6, and this would be like an open circle. I'm going to say open circle at 6, and it's going to be less than that, right? Now my second statement says the x's have to be greater than negative 2. So on the number line, let's say negative 2 is right here. If I were to write x is greater than negative 2, that would be an open circle at negative 2 going to the right here. So basically my graph is just going to be this connected interval from negative 2 to 6, not including those endpoints. So we can think of this as an AND solution. X is less than 6 and X has to be greater than -2. And so there is my graph. Now you could also write this in a kind of a shortcut way, which you could have actually done from the start. And I'll go over that as well. So yeah, you could write this as X is greater than -2 and less than 6. You could write it like that as well. You could write it like this. You could kind of write it out in the long form right here. Or you might see an answer like that, which is more of kind of the compact form, right? And so there's our graph. And that's what we have here, okay? A really kind of easy way to remember if we're going to have a connected interval or a disconnected interval, at least the way I do it, is I just look at this original symbol. When we kind of get to after step 1, we have a less than symbol. We have a less than symbol, it's always going to give us an AND inequality, always going to give us a connected interval here, because we're saying this absolute value, right, this distance has to be less than 16, less than this number from some sort of middle, right? You can think of there's, some sort of middle in this interval, and we're saying everything that I'm going to shade is going to be less than some number. And so that's always going to be a connected interval. It's always going to be an interval that has a left side, has a left bound, has a right bound, and kind of everything within that proximity is going to be included in my solution. So, and then vice versa, if it's a greater than symbol here, it would be an OR inequality. So you'd have two things that are going away from each other, right? So again, kind of reviewing the steps, same thing as an absolute value equation. The inequality, we're basically going to isolate the absolute value term and then create two different inequalities. The second one, we reverse the symbol and we take the opposite, and we get our full solution there.